everyone. In this video, we're going to look at a computer skill lecture that is related to how to calculate confidence interval for your population mean, mu, when sigma is unknown. So in the lecture, we mentioned if your sigma is unknown, instead of using the z statistic, we're going to using the t statistic, right? So let's look at it together. A random sample of 5 shipment of stick-on labels shown the following order sizes: 12,000, 18,000, 30,000, 6,000, and 40,000. And so first question is related to, hey, the differences between the t-stats and the z-stats. Okay, so if you are looking for 95% confidence, 80% confidence, what is the t-stats value accordingly, and how different are they from z-score? So basically question number A is help you to practice on, hey, how to get the t-stats. So in the previous question, question number 3, and question number 3, I already show you how to get the z-stats, right? So we just need to compare the t-stat and to learn, hey, how different they are from the z-stats. Okay, so first of all, in order to calculating the t-stats, in the lecture we mentioned, first we need to know the degree of freedom, and the second is to know my confidence level, right? So in this specific question, we are looking at 2 scenarios. One is 95% confidence interval. The other one is the 80% confidence interval. Therefore, we need 2 separate t-stats. Okay, so let me figure out df for question number 8. Okay, t for 95% and a t for 80%. And I'll also do z for 95%. And then the z for 80%, right? So we had to do this 2 scenario. So in order to do that, we need to know the degree of freedom for the t. So degree of freedom we learned in the lecture. Let me go back if you don't remember. So when we calculate degree of freedom, is equal to n minus 1 because we're losing 1 degree of freedom when we calculate the standard deviation. So therefore, in this case, our sample size, since we have 5 observations, right? So the degree of freedom here will equal to 5 minus 1. So that gives us 4. Okay. And the second is related to the alpha value. So the alpha value, remember the alpha always equal to 1 minus. Okay. Alpha always equal to 1 minus my confidence interval, right? Here, the first one, 95%, is equal to 1 minus 0.95. So the first alpha is 0.05, right? First 95% confidence corresponding to alpha equal to 0.05. And for 80% confidence interval, the alpha equal to 1 minus 0.80. Okay, so the second one, the alpha value equal to 0.2. Okay, we can use the same for the other, for the z-score too. Okay, so I got my alpha. So now we're going to use in the formula I introduced in our lecture. Remember, it is t.inv.2t, and we use alpha value and then degree of freedom. That will give us the t statistic. Okay, so for the 95% interval, it will be t.inv.2t, and then parentheses, the alpha here, we can just select, and then degree of freedom. So you also can type in the value, right? The first alpha is 0.05 and a comma and 4. Okay, so the t-stat for 95% confidence interval for this specific case is 2.77648. And then for the t, for the 80% confidence interval, t.inv.2t, parentheses. And the probability here is the 0.2. And then the degree of freedom here is here 4. Okay, it's 1.533 as we mentioned about. So if you want to have a narrower interval, you need to making your confidence level, reduce your confidence level there, right? Okay, so now let's think about the z-score. So the z statistic we learned from the previous computer skill lectures, and so the formula we use is norm.s.inv. So in this one, we only need our one value, which is a probability. So this probability is calculated by your confidence level. So the first is 95% confidence level plus your alpha divided by 2. So that will give you the z-score if you are using the z-score for this situation. And so for the, so you can see, since our sample size is small, the 95% confidence in 95% t stats is very different from the z stats, 95% confidence z stats, right? So it's very different. Okay, now let's look at 80% confidence interval, NORM dot S dot INV. So if you don't remember here, make sure you watch the previous lecture where I cover how we are using this probability value. So it will be 0.8 plus 0.2 divided by 2. Okay, as you can see, for the 80% interval, the t stats versus z stats, they are still very different. Again, the reason is because my sample size here is very small. Okay, so this is the question number 8. What is the t stats and the z and compare that with the z stats? Okay, now the next is question number B. We are construct a 95% confidence interval for the true mean order size. Okay, so to answer that question, we need to leveraging the formula we learned here, right? Let me go back here. So this is the formula we need to use. We need to use the sample mean plus minus the t-stats. We know how to calculate t-stats now, and times the standard deviation, sample standard deviation, and divide by square root of n. Okay. However, as you know, at this point, based on the question, we only have sample data, 12,000, 8,000, 30, 60, and the 1,4,000. So what are we gonna do? Let me put that here. So we currently only have sample data, right? So in order to calculate the interval, we need to know the value for x bar, and this instead of sigma, we call it s now because it's estimated. And so to getting that, we need to base on my sample data to calculate the mean and the sample standard deviation. So for the data, it has to be ordered in the vertical line. So therefore, we need to move everything to vertical. Okay, so now for my original data is horizontal, we need to make sure they are only in one row, one column. So once you make it as one column, then you can use the formula we learned in chapter 4. So for the sample mean, we are using average. And then we select my number and the close parentheses. So that will give me my average. And for the sample standard deviation, as is the STDEV dot S. Remember, it's a sample, so therefore it has to be dot S. And then we select. So now we are able to get in our x bar, s, and for my confidence level, so this is the 95% confidence. My alpha is equal to 1 minus confidence level, right? Give us the alpha value. Now we can calculate the t-stats again. Again, the degree of freedom we already calculated, minus 1, right? So the t-stats equal to t dot inv dot 2t parentheses. So the probability here, we are using the value for alpha, and the comma, and then degree of freedom, and close the parentheses, and push enter. So now we got our t-stats value. Now we just we have every component we needed to form this formula. Now we can do lower bound and upper bound. So we are able to calculate my boundary now. Okay, so for my lower bound, it is equal to, based on the formula, I'm going to select my x bar, and then we're using the minus sign, right? And then find the t-statistic we just calculated, okay? And then times the standard deviation, sample standard deviation, divided by SQRT, oops, parentheses, square root of sample size n, we have 5, right? And close the parentheses. So this will give us the lower bound for this example. Now we are calculating upper bound. So equal x bar plus, okay, plus t statistics times the standard error divided by s square root, parentheses, sample size, close the parentheses, and then push enter. So now I'm able to get in my lower and upper bound for this case. Okay, so again, if you think I walk through here a little bit fast, as I go through these formulas, make sure you pause your computer and then follow to get the select the right cell and push enter. Make sure the number also match my answer too. So that is how you are able to calculate the lower and the upper bound for the confidence interval when you do not know the population standard deviation. Okay, so good luck with your learning, and again, you will see a very similar question in your homework assignment. So make sure to follow this this solution to work on your homework. Good luck. Bye.